Hello and welcome to video 3 of the Intro to SPSS 26 on AU apps. In this video, we're going to talk about how to run an independent samples t-test, how to check for the equality of variances test within there too, make sure that assumption is not violated. We're also going to talk about how to run a one-way analysis of variance, test the assumptions, and interpret the results as well. So looking back at what we did previously, we recoded variables, we did some quick visualizations, and did a t-test. I also want to mention too that within this, if you want to make edits to the visual itself, you can double click here. That's going to open up a new box. They can actually edit the visual itself. You can change the colors, you can change the labels, and so forth here too. If you want to run SPSS while having this open, that's going to be a problem. So you need to make sure once you're done, go ahead and exit it out. That way it closes that chart editor. So now what we're going to do is we're going to run an independent samples t-test. So this is going to ask a question specifically comparing two means for different groups. So we're going to determine whether the GDPPC differs based on the corruption categories we did earlier. We're going to explore the differences in the mean for each category, then create a bar chart, and then run a t-test, and then run an Anova for two or more groups, or for more than two groups. So to start, what we're going to do is we're going to look at the descriptive statistics for GDPPC based on what group they're in for corruption categories. So what you want to do is click first on Analyze. And it doesn't matter if we're in the output window or in the data window, this ribbon will always work the same. So click on Analyze, Descriptive Statistics, and we're going to click on Explore. I'm going to right-click here, change this from variable labels to display variable names. I'm going to scroll down and find our GDPPC, move that to our dependent list, and move corruption categ to our factor list. Now I'm going to leave this as display both statistics and plots. I'm going to click in statistics. All that looks good. I'm going to leave that alone. For plots, I'm going to change stem and leaf to a histogram. Click on Continue, and then click on OK. So this tells us the valid percentages for each and how many we have. We have 6 that are missing for high. It tells us based for GDPPC, what are the descriptives based on what group they're in. So if they're in the low group, what is their mean GDPPC? What is the standard deviation? If they're in the medium corruption, what is their mean? What is their standard deviation? If they're in the high, the same information there. We can also look at skewness and kurtosis. So kurtosis, is it a normal distribution? Is it a flat distribution? Or is it really peaked? We also have skewness. Is there potential outliers? Is an extreme score pulling that one way or another? So we can kind of look at the histograms. So see, this might be for the low group, for corruption categ, there's might be a potential outlier here. So that's that might be pulling that distribution, but might be pulling that mean, that measure of central tendency. We have our box plots here too. So this tells you the quartiles, the bottom 25, the middle 50, the upper 25, and then the median. And then anything with an asterisk is a potential outlier. It will tell you the number of those values too. So potentially we might want to run the analysis with 116 and 39 and then without it and see the differences or remove those outliers, what that does with the analysis. Okay, so what I'm going to do now is we're going to create a bar chart. We're going to go to Graphs, click on Legacy Dialogues, and click on Bar. We're going to go ahead and keep it as a simple, and click on Define. And then what we're going to do is we're going to select Corruption Categ. So if I right-click for variable names, we're going to go ahead and move this to our category access. And now what we're going to do is we're going to, for the bar represents, we're going to change it to other statistics, e.g. the mean. I'm going to take our GDPPC and put that there. We'll look at the mean of GDPPC and click on OK. So these are our average GDPP scores for each groups. Notice that low corruption on average had a much higher GDPPC compared to medium and compared to high. This does not tell us whether these differences are statistically significant though. Let's say that we wanted to compare two groups and only two groups. So we'd have to use a t-test. If it's more than two groups, it'd be an Anova. So t-test is the most basic way to compare two groups based on their scores on a single value. While we divided corruption 2 into 3 groups corruption categorized, we can only compare two groups at a time using a t-test. So what we're going to do then is we're going to compare the medium with the high. See if that difference is statistically significant. The null is that the means of those are not different from one another. So I'm going to go to Analyze, Compare Means, and I'm going to go ahead and click on Independent Samples t-test. I'm going to right-click here, change it to Variable Names. I'm going to find our GDPPC and move that to our test variable. I'm going to scroll down, get corruption categ, and move that to our grouping variable. Notice there's two questions marks here. That's saying, okay, what groups are we interested in looking at? So we actually need to define the specific groups. I'm going to click on Define Groups. Now the medium corruption, that's a 2. Based on our coding before, I'm going to give that a 2. And our group 2 is going to be 3. That's our high group. I'm going to click on Continue, and then click on OK. Great, so now what we're going to do is we're going to look at the output together. Looking at here, this is our group statistics, the same information we had previously in our Explore tab. So if I scroll all the way, it's the same information. But we really want to focus here. Now, before we interpret these rows, there's two rows, equal sums or equal variances assumed, equal variances not assumed. Now, an assumption with t-test is the variability of scores around the mean for group 1, or whatever group you're comparing, is really similar or practically equivalent to the variability with the other group. If there are massive differences in the variability, then we need to correct for this. So we lose degrees of freedom in order to then make the comparison. So this is actually a test that we want to be not statistically significant. So we're going to compare these columns here that says Levine's test for equality of variances. If there's a high F and the p-value is less than 0.050, that means we're rejecting the null, that the variability is not statistically significantly different from one another. Because we violated that assumption, we cannot interpret this first row. Instead, we would report this, the F and the significance for the Levine's test, but then we would interpret this bottom row. So we have a new t, which is 8.72 with 60 degrees of freedom. We lose a lot of power here for this correction, but that's okay. Our significance tested is still below 0.050, so p is less than 0.001. The mean difference between the medium and the high is 9,438.245. And we can't fit a 0 between our upper and lower bounds here. So what this tells us is that the probability of getting this result, given the null is true, again, in general, looking for p-value less than 0.05, that these two groups are statistically significantly different from one another. Great. So now what we're going to do is, let's say we wanted to compare more than two groups. So we have 3 groups here. Let's say we want to compare all 3 of those. The null hypothesis is the mean of group 1 equals the mean of group 2 equals the mean of group 3. If any of those groups are not equal to one another, we're going to get a significant one-way ANOVA. From there, we need to run a post-hoc test to figure out, okay, where are the differences? So what I'm going to do now is we're going to go to Analyze, click on Compare Means again, but now we're going to go ahead and go down to one-way ANOVA. I'm going to scroll down. Actually, I'm going to right-click here, and I'll move corruption categ to our factor. Move GDPPC to our dependent list. Now, what I do now is I'm going to say, okay, if there are differences, because we know right now that medium to high is significantly different from one another, you wouldn't do it in this order. Technically, you do it the Omnibus test first, and then look at the post-hocs. You wouldn't do the t-test first, but this is more conceptual though. I'm going to click on Post-Hoc Test, and what I do is I'm going to select the LSD and Bonferroni. LSD is a very liberal post-hoc test. Bonferroni then tries to preserve and reduces failing-wise error rates. So let's say you ran 100 t-tests, 5% of the time, because we have a p-value of 0.050, 5 of those 100 t-tests are going to be statistically significant and spurious findings. This is kind of preserving for that error rate, sometimes called family-wise error rate. And if equal variances are not assumed, I'm going to go ahead and maybe select games how for this one and click on continue. So again, like we did the Levine's test, we're going to get that assumption, and if we violate that assumption, we have a different comparison than we look at. I'm going to click on continue and then click on OK. So we have a whole lot of information here. We have our Omnibus Anova test. Are there differences here? So our between and within. Based on this, our F statistic is 219 with a p-value less than 0.050. So this is telling us that, yes, there are significant differences here. We also have the post-hoc comparisons. This is each of the comparisons. And actually looking at this, we did not have a Levine's test. So actually we need to go, I goofed up on this. Let's go back into Analyze, click on Compare Means, one way Anova. We need to click on Options. So I'm going to click on Descriptives, click on Welch, Means Test, and Homogeneity of Variances, and click on Continue. And then I'm going to click on OK again. So I'm going to ignore that top part. So descriptive statistics we had before, based on the mean, we did violate that assumption. So when we do our interpretations, we're going to want to interpret the game's how comparisons. Looking at our Anova, we can say, okay, it was statistically significant, so there are differences somewhere in here. And then we can start looking at our comparisons. And again, because we violated an assumption, we're going to look at the game's how and see, okay, where are those differences? So this is low compared to medium, low compared to high, and essentially it's a t-test, each one. This is a mean plot to kind of show us where the differences are as well. Now the output is a little bit more complicated. The models does tell you what the differences are here for the between in there, and that there's significant differences between groups. You report it as F parentheses, your 2, comma, 148, so you're within and between degrees of freedom. Your F equals F statistic, which is 219.11, and your P is less than 0.001. You would report all that. And then there's specifically where those differences are in the t-tests. Great, so this concludes video 3. In the next video, we're going to talk about correlations and regression.